This is the lesson for Handout 3A. And so taking a look at our first problem, the length of a rectangle is 3 inches less than twice its width. So let's go ahead and draw a little picture if we're a little unclear about what is going on here. And here's my rectangle, and the length of the rectangle is. So when you see the word is, think of equals. And so L equals 3 less than twice its width. Well, if I say W is the width, the equation or the expression for the length would be twice W, so 2 times W, minus 3. So 3 less than means you're taking 3 away from twice the width. Now we're supposed to find the area. Well, all we have to do is remember that area equals length times width. But instead of L, we're going to use the expression that we have right here, 2W minus 3. And then over on this other side, we're going to just use W, and we're going to multiply W times these values. And so when I do that, I end up with a 2W squared minus 3W. And that would be the area. Well, from there we can go ahead and do the next one. It says if a number is squared, so if a number is squared, we don't know what the number is, so let's do this. Let's call x the number. A number is squared, so x squared. The number is squared and added to 4 times the same number. Okay, added means plus 4 times the same number, x. The sum is means equals again, equals, and then 77. And so now we can go ahead and solve. So we've got a choice. We can either solve by completing the square or factoring. So let's go ahead and try completing the square this time, because it's kind of set up for completing the square. So the way I do that is I take the 4 and I take half of it. And I'm thinking about what I need to add to make a perfect square. And if I am not sure, I take half of the b term, and that makes 2. So the 2 values that go inside the parentheses need to be 2. So it needs to be x plus 2 and another x plus 2. Since they're exactly the same, we're going to write that as a quantity being squared. So they'll figure out what it is I need to add to both sides. I square that number. See, the last terms are going to multiply to make 4 because they're both 2. And that's what I need to add to both sides. So I'm going to add a 4 to both sides. And so when I do that, I get a perfect square trinomial, which I factored already as x plus 2 quantity squared, and it equals 81. How did I get that? Well, I added these two numbers together, 77 and 4. Well, from this point, I can take the square root of both sides, and that'll cancel out the squared symbol, leaving me with this x plus 2 equals plus or minus 9. Well, 9 came from the square root of 81. And so from that point, all you have to do is subtract the 2 from all sides, and you set up 2 problems. You've got x is either going to equal 9, positive 9, minus 2, which makes 7, so that's one of the answers, or negative 9 minus 2, which makes negative 11. So negative 11 and 7, those are the 2 x-intercepts. Those are the 2 values that would work for this expression, for this problem. So we get to complete the square a few more times here. So let's do that. It's set up for completing the square on this problem. So take that negative 10 and take half of that number. That makes negative 5, and then you square it. Now, why do I square it each time? Well, because the factored form is going to be x minus 5 and x minus 5. And you see when I'm using the FOIL method, the last terms get multiplied, but they're exactly the same. So that's why I'm squaring that value. And so I always look for the 2 numbers that add to make negative 10 and then square that value, and that's what I add to both sides. So I'm adding a 25 to both sides. Now it's real important to add it to the right-hand side over on this side here, this 25 plus this 24, because that's what it's going to equal. The quantity squared is going to equal. It's going to equal 49 in this case. And so when I go ahead and take the square root of both sides, squared symbol is going to cancel, so I'm left with an x minus 5 equals plus or minus 7. And so from that point, I just need to add the 5 to all sides. And so when I do that, I end up with a 7 plus 5 and a negative 7 plus 5. So that's how I'm getting those 2 answers. I get one of them as 12, the other as negative 2. So those are the 2 x-intercepts. I can go ahead and put them in my set of braces to show the solution set. So here's the next one. This one's not set up for us. So we have to move this term over to the other side by taking it away. So whenever you move a term, all it does is switch signs. So now it's a negative 2x and a positive x squared, and this all equals 6. So I go ahead and figure out what half the b term is. So half of this term, negative 2 times by a half, makes negative 1. I take that negative 1 and I square it, and that gives me 1. So that's the number that you end up adding to both sides. So I go ahead and factor this, and it always factors to half the b term, because the two numbers need to add to make negative 2, but multiply to make positive 1. And negative 1 and negative 1 are those numbers. And this all equals 7. So we go ahead and take the square root of both sides. And in this case, we're going to end up with an irrational root, or irrational roots. And so we have x minus 1 equals plus or minus the square root of 7. Irrational because we can't take the square root of 7 without approximating it. And so we're going to leave the answer as an exact answer here in the form of the radical. And so we end up with x equals 1, positive 1, that's this number right here, plus or minus the square root of 7. That is our answer. This next one is, again, not set up for completing the square. So what we need to do is move this x squared term back to the other side. And so when I do that, now I have x squared plus 4x equals 7. So I left some room here because I need to add a number to both sides to complete the square. So to figure out what it is, I have to take that 4, take half of it, and that gives me 2. So 2 is the number that goes inside the parentheses, x plus 2. And it's a quantity being squared. So the way I figure out what it is I need to add to both sides is I take that number and square it. And that makes 4. And that's the number we add to both sides. So when I do that, I end up with 11. Now where did I get 11? Right here, 7 plus 4. When I added 4 to both sides, I have to add 4 to the 7, and that's how you get 11. And so from that point, I take the square root of both sides, and I end up with this x plus 2 equals plus or minus the square root of 11. And so I just have one more step. The last step there is to subtract the 2 from all sides, and I get my answer. X equals negative 2, so negative 2 because I took away 2, plus or minus the square root of 11. And that is the exact answer. Well, we also have some problems that ask us to factor. So when we factor, we always want to set it equal to 0. So factoring is sometimes a little faster. That completing the square is a good method as long as we have just even numbers we're taking half of. It gets a little bit more complex when we have to deal with fractions. And so factoring is always a method that I always fall back on because I feel that it goes a lot faster. It's just a lot of thinking of numbers that multiply to make the last term but add to make the middle term. So I went ahead and added 16 to both sides. So I've got this x squared plus 10x plus 16 all equals 0. So when I go ahead and factor, I'm looking for numbers that multiply to make 16. So when I think of those, I got 4 and 4, 16 and 1, but 2 and 8. Those are the numbers I'm going to pick because those add to make 10. And so now I need to solve. To solve, I use that zero product property. So I set the two factors equal to 0, and I go ahead and just do an opposite operation. So I'm taking away 2 from both sides. Here I'm taking away the 8 from both sides. And so I end up with those two answers. Negative 8 and negative 2 are the two x-intercepts, two values of x when y is 0. This next one, again, you got to set it equal to 0, so I need to move that 3x squared back to the other side, and I have this 3x squared plus 18x equals 27. And so this is all set equal to 0 now. And now before I just go ahead and draw the two sets of parentheses, I'm going to take out a common factor. You see, 3 goes into all these numbers. So pull the 3 on the outside, and I have an x squared plus 6x plus 9. Now the problem's a little bit easier to deal with. Now that 3 does not affect the x-intercepts, so what I'm going to end up doing is I'm not even going to deal with that. I'm just going to go ahead and factor that trinomial that I have. And that's going to be an x plus 3 and an x plus 3. And so I go ahead and set those factors equal to 0. And really, I only need to set one of them equal to 0 because the other one's exactly the same. So when I go ahead and do that, I end up with a negative 3 as the only x-intercept. And this next one, we're going to take away the 12x from all sides. Now notice that I put the 12x in a certain spot. I put it in what we call descending order. Descending order goes from the highest exponent to the lowest exponent. The constant is last. And this way you can see the factoring a little bit easier. And so the numbers that multiply to make a positive 36, but subtract to make, or add to make negative 12, have to both be negative. So it's negative 6 and negative 6. And so when I figure out the value of x when y is 0, I just have to do one of them because they're both the same. So I do that work and I end up with x as positive 6. So those are some of the problems that you'll see on Handout 3A. There's more problems on Part 2, so check that out.